think it's very difficult to solve this problem with the computing methodologies we know. It's very difficult. Why? Because it's on meaning. And if computing with words does not attack the problem of meaning, it will be nothing. It will be another computer methodology. But it will be not a science. It will be not a science. This is my point of view. And I am interested in computing with words because I have the feeling that with these ideas around computing with words that are unshackled. with these ideas, maybe we can find something new. For example, new models of fuzzy logic, non-commutative, non-associative operators, different ways of representing rules, or representing larger rules. Not only this is x and 10, but more sophisticated kind of rules, that is conditional expression. This is my point of view. And I agree a lot with Claudio in this view that, well, because I think that at the end of your talk is this, competing with coffee, patent pending. Who is to patent something based on computing rules? Who is? Which company will sell this patent? That is, which problems you will try to solve with computing rules? I think this is the basic point. And because of that, I think there is very few people around the world that they say are working on computing rules. Maybe 20 people around the world, no more people. But these people is very risky people. Because they can fail very easily. And then they will disappear from the table of researchers. Then it should be careful with computing rules. That's my view. And because of that, when Nokia starts to organize a workshop and to prepare a book, I am afraid that it's not the right time again. Too early. It's too early.
Yeah. Okay, let me try to summarize some points. First of all, I totally agree with you. Like many people have been doing or pursuing in one way or another computing with words, in the sense that trying to leverage the level of the programming languages, the leverage of the abstraction used to programming, like introducing the object-oriented programming languages that is getting higher and higher abstraction, so it gets close to the designer or to the human. They have to program the system to do something. So in that way, this is true. But also, I think Sade tries to remark that because of the huge computational power that we have now, the more or less nice results got just by making more and more complex numerical crunching processes. This goal is forgetting. Like, people is more focusing in, okay, let's just buy a bigger machine, let's just introduce more complex algorithms and differential equation and so on to solve all the problems. So most people is forgetting about that goal, that getting an easier way to program, design, and understand computational system. Because now it's much cheaper wait 6 months to Intel to solve your problem, because it will introduce like a Core 3 or Core 4 or whatever. And you just say, oh, I just have to wait. I have more number power and computational power to solve the problem. To me, the problem is also that when the problem gets very complex, and also the machine now is getting very complex, because it used to be really simple. Everybody more or less understand what the code was doing. Now we have multi-core, multi-thread, parallel, so many things that even the programming doesn't know what is going on. So it's becoming more and more complex even to design debug or to implement new systems. And I think, to me, even though competing with words is only a target, it's not a reality, it's just a lighthouse in the far way, I say, like trying to tell everybody, okay, don't forget about that you should use words and something that you understand to define the system, so you will be able to know what is going on in the system. So interpretability is a very important thing that I'll also know about it, because when the system is very complex, if you don't understand what is going on, it's almost impossible to debug or understand. And also to specify, if you know the mathematical equation, maybe you just can program it, but if you don't know, what is in most cases you don't have any clue how to even make a mathematical model of it, you start doing a specification with words. And then from that you try, okay, now I want to model all these words, I'm going to translate this word. Maybe you can translate to a fuzzy set, you can translate to a function, you can translate to a program, you can translate whatever you want. But you have to have this kind of management of the words and the computational counterpart, that you have these two levels. One that you understand as designer because you know what you want to do, and another level that is performing the operation, and you have to have this link between both. So that is more or less to me what,
Yes, there have been a lot of that in the past.
Yeah.
And other names.
Mm-hmm.
All efforts in software engineering to have specification languages, which after that they are translated into programs. All the development of UML to specify your program.
Yeah.
Specify what you want to do, because it's so complex you cannot start in the good old times writing immediately a program in Fortran 2, because your program was 100 lines long and that was a very long program. Now you have megabytes of program, text. So you cannot do that. You have to start at very high level, specify. And in software engineering, there's a lot of efforts and very successful to do formal specification, but still you have a lot of natural language there. So much natural language of control. And then there are systems that allow you to translate that into real program. So this has been done. And there are names, other communities, and of course I don't talk with them. That's another principle. He's a software engineer, he has no idea of what is software computing, and the other way around. I think that we also need to, again, spring up our own shadows and try to see what the other guys are doing. Some of them are doing things very close to this and the other names, and they have 20 years of experience doing that, what we are starting to reinvent. Reinvent the wheel might be very nice. I will be very careful to start from scratches, doing everything again on my own. Of course, I did it. Now, first look what the other hand has done. There's a lot of work that in this same line of questioning that was done in the early times of expert systems. And expert systems have programs written in whatever language you want, probably this, and some others. But they have this kind of dialogue also that the program would ask the user. There was a typical example, what was the name? One early expert system for economic advisement. Was typically that somebody would ask, I want data of this stock market, this, and this. You obtain the answers.